Hi, this is Tom, and welcome back, because in this problem, what we're going to do is we're going to start by taking our previous problem, marbles in the bag, and we're going to copy this, and we're going to just make one subtle change that makes a big difference. Let me show you what that is. We're going to take a look at what's called hypergeometric. Hypergeometric distribution. And so I know it sounds big and fancy, but what it means is that now the events that we're looking at are dependent. That's all it means. It means that we have dependent events. So let's make that note. Dependent events. Trial. All right, we should probably use trial. Okay, so here's how the problem changes. It's the same problem. It says a bag contains, or similar, a bag contains 3 red marbles, 4 green marbles, and 5 yellow marbles. Find the probability of selecting 2 red, 2 green, and 2 yellow marbles. After a marble is drawn, and then here's what we want to change. The result is recorded and the marble is not returned to the bag. And when we do that, we call this without replacement. So those two little changes, I know they seem so small. This one and this one change the whole outcome of our problem. Well, let's see how. Well, believe it or not, that the problem solving doesn't change at all. We begin by writing one way to be successful. So let's see. We could get 2 reds, 2 greens, and finally we could get 2 yellow marbles. Now, notice how the problem changes, because the probability of first drawing a red is 3 out of 12. Now, when you go to draw another red, there's only 11 marbles in the bag. So now the probability of another red, well, there's only 2 reds left, times. When we go to draw a green, there's 10 marbles in the bag. And initially, there's still 4 greens. We continue this, but now when we go to draw the next marble, there's only 9 marbles in the bag and only 3 green ones left, times. There's now 8 marbles left, and 5 of those are yellow, times. There's 7 marbles left, and 4 of those are yellow. And this changing of the probabilities is a result of withholding the marble. But we're not done, because this is only one way we may be successful. We need to remember that RR, GG, YY, this is a word. All right, so here we go. If that's a word, then we need to say, okay, this is 6 factorial over 2 factorial for the R's, 2 factorial for the G's, and 2 factorial for the Y's. All right, so with that in mind, let's try this one. Let's try this one just like we did for the last one. See if we can cancel and reduce and get the right answer. I always like doing these. So copy that, put it down here. Get it probably about there, so I have some space. Let's grab a color. How about we start with yellow? Notice that right off the bat, I have a 3 times a 4. Well, that's 12. Let's do another color for our next cancellations. Notice I have a 2 times a 4. Well, that's 8. And let's try another one. How about a pink one? What do we have for pink? Notice this. Let's take our 6 and remember that it's 6 times 5 times 4 times 3 times 2 times 1. Well, wait a minute. 2 times the 2 factorial, 2 factorial, 2 factorial, that's really just 2 times 2 times 2, which is 8. And notice that 4 times 2, that's 8 as well. There we go. We have a little bit more canceled out. Let's make another one. See if there's any more in here. And I think I see, here's 3 times 3. 3 times 3, that's 9. And let me see if I have all of those. Then I have, oh, look at this. Here is a, got another one in here. Let's put another color, about blue. So here's a 5. That would cancel the 10 to leave a 2. Oh, and then that 2 will reduce. So let's do that in this nice purpley color. So this 2 will reduce a 6 down to a 3. And let me see, what do we have left here? I have, just double checking, I have, yeah, that should work. So we write down what we got now. We have a 5 times 3 in the numerator, and we have an 11 times a 7, and we can put all that together for 15 out of 77. Now, that's one way to get the answer, and I think that's the most intuitive way, but a lot of people like this next way. And here's what they would do. They would say, all right, well, I need to get 2 reds. There's 3 available, so I would say of the 3 reds, I need to choose 2 times. There's 4 greens available, I need to choose 2 of those. Times. There are 2 yellows, or I need 2 yellows, but there's 5 to choose from, so 5 choose 2. And then what I would do is I would divide this by all the possible groups of 6 marbles that could be chosen. So if you work through this, and I would encourage you to do that, and actually we'll do that here. So this is going to be a big fraction, but let's give this a shot. So 3 choose 2, that's 3 factorial over 3 minus 2 factorial 2 factorial times 4 choose 2, well, that's going to be 4 factorial over 4 minus 2 factorial 2 factorial times, we have a 5 factorial over 5 minus 2 factorial 2 factorial. All of that is over a 12 factorial over a 12 oops. There we go, a 12 minus 6 factorial, 6 factorial. So this is going to take me a few steps, but we'll try this. So 3 factorial, remember that's 3 times 2 times 1. 3 minus 2, that's just 1 factorial, or 1, and 2 factorial is 2 times 1, times 4 factorial, that's going to be 4 times 3 times 2 times 1, over a 4 minus 2, that's 2 factorial, and that's another 2 factorial, so if you multiply those together, you get 4, times 5 factorial is 5 times 4 times 3 times 2 times 1. 5 minus 2, that's 3 factorial, that's 3 times 2 times 1. And 2 factorial is a 2. Excuse me. So let's try this. Then in the denominator, we're going to have a 12 factorial. That's a big one. Well, that's 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over. And remember, if you just want to go straight to your calculator, that's okay. I'm really just showing you that this does, in fact, work. So 12 minus 6, that's 6 factorial, so that's 6 times 5 times 4 times 3 times 2 times 1. And then we have another 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. All right, so let's make some cancellations here. So my first one, I have a 2 times 1 and a 2 times 1. And then here I have a 4 and a 4. And let's go look at our next fraction. Here I have a 3, 2, 1 and a 3, 2, 1. Oh, and look again, notice that we have a 2. Well, that'll reduce that 4 to a 2. Okay, so with that, let's see. That gives me a 3 times 2 times 1 times 5 times 2 in our numerator over. All right, we're going to do some more canceling here. Here's a 6, 5, 4, 3, 2, 1. Here's a 6, 5, 4, 3, 2, 1. And let's see, how about, oh, here's a 6 times 2. Well, that's a 12. And let's try another color. How about, ooh, that's a tough one. Well, I have a 5. And that'll make the 10 into a 2. And then notice, then what do we got? Let's get another color here. I'm running out of color. Here's a brown. I don't think I've used the brown before. Notice that I've got a 4 here. Oh, here's a 3 and a 9. That'll make that a 3. And then I have, we'll do it, not a yellow, pink. We'll do a pink here for a 4 cancels into the 8 to give me a 2. So I'm going to write what I have. Notice that down here, this entire denominator has been canceled. So the only thing that goes in the new denominator is, if we go through and pick these out, it looks like I have 11 times I have a 2 times I have a 3 times a 2 times a 7, and that's it. And now let's see if there's any more simplifications that can happen. We'll start with yellow. Here's a, ooh, look at that. Right off the bat, here is a 3 and a 2 and a 2, and here is a 3 and a 2 and a 2. I think that's it. And if we multiply those back together, notice I have a 3 times 5 left in my numerator times the 1, but that doesn't change anything, and 11 times 7, and there it is, 15 times 70, or divided by 77. And that is how you work a hypergeometric problem. Notice that it's very similar to the multinomial problem. It all begins by writing out one way to be successful, then writing the according probabilities, multiplying by the word, and you should have the right results. Hope that helps, and thanks for watching.